So my name is Francesca Ferlaino. I'm professor at the University of Innsbruck in the Institute for Experimentalphysik, and I'm also one of the director of the Institute for Quantenoptik and Quanteninformation of the Austrian Academy of Science. So I'm an experimentalist and I'm working in the topics or in the research area of quantum physics, and in particularly I'm using atoms in a very special regime where atoms are extremely cold. And in this specific regime, the atoms are to behave not as a classical object, but as a quantum object. That means that they start to have some wave behavior instead of point particle. We know in our community now pretty well how to manipulate the atom with laser light and how to trap these atoms using magnetic field or using again laser light. This we know, so the technical path to reach the quantum regime is known. What are the hypotheses we need to use is then what happens in this quantum regime. There nobody knows, and there is no precise theory that it's able to tell you exactly what is happening, because you have to imagine that this condensate or this degenerate gas, we also call it, it's composed of something like 1 million of particles that they interact all together. And there are no exact solution of this problem, and the hypotheses rely to the different model we test and we use to understand the system. Because this basic question at the base of future really technological revolution, not small improvement, but really the possibility to have really technologically different environment. The magic things of being really as physicists is that we can build up models which are based on approximation that can describe also what we cannot solve exactly. Okay, this is the key point. And how do we know that what we describe is well described? So we know it because we can test it. And for example, ultra-cold atoms, the atoms which I work with, these are kind of a test system for new theory. From a psychological point of view, it's fascinating that you are exploring basic research and you don't know the answer of your exploration. So it's very fascinating that you have to keep your mind very open. It's fascinating that many times you have surprise. So imagine that now you has the ability to look at single atom. You have the ability to see how single particles behave, the ability to cool down so much this atom that they almost don't move anymore, and what they do on the other hand, they become wave. So this is very fascinating, the system itself. For me, the START Prize had an extremely important impact, I have to say. Everything changed since I had this START Prize. And the reason is because so I was a postdoc, and then thanks to the startup money and prize, I was able to do the step in which I could finally build my own experiment. So kind of build up on my own idea, get some independency, get my working group. Also very important was that I developed this in Innsbruck, which is a fantastic host institution for kind of this junior group and to let this junior group growing. Without the START Prize, I mean, it would have not been possible, or at least not at this time.